Hi, this is Mrs. Vrobel. So I got a request to show you guys more ice tables. That way you figure out how to solve these things. So I'm going to use this problem here. And notice that I've got one reactant and I have two products. Now, they say that for this reaction, the equilibrium constant is 1.6 times 10 to the negative second. Okay, and then they want to know what is the moles of each substance at equilibrium. So the first thing I'm going to do is I'm going to set up an ice table. And notice they tell me that we're starting with 0.1 moles of HBr. We have no product. Now notice that we have a 1 liter vessel, so we need to factor in the 1 liter. For the change, we're going to say that we're going to lose 2x because of the coefficient, and we're going to gain plus x for hydrogen and plus x for bromine. Okay, and then for the equilibrium, we essentially have to add everything up. And I want to set up my equilibrium expression. So I want to say Kc is equal to products over reactants. And remember, HBr, the concentration is going to be squared because of that equation. So what I'm going to do is I'm going to say x squared, because x times x is x squared, over 0.10 moles over 1 liter minus 2x. And that is squared. Okay? And I'm going to set that equal to the Kc, which is 1.6 times 10 to the negative second. Now notice that on the left-hand side, I have both of them are x squared. So I can get rid of the x squared by taking the square root of both sides. So I'm going to do that. Sorry, I lost my x there. So when I do that, I end up with x over 0.10 moles over 1 liter minus 2x. And that's going to be equal to 1.6 times 10 to the negative second. Okay. Now I think I'm going to move this over just because I'm running out of room here. So when I solve for this, it becomes 1.6 times 10 to the negative second times 0.10 moles over 1 liter minus 2x, and that's equal to x. So you want to essentially carry out the sorry, I'm running out of room here. I got to make this a little bit smaller. Okay, so I want to take 1.6 times 10 to the negative second, and I want to multiply it by 0.1, and I'm going to make this molarity minus 2x, and that is equal to x. So when I take 1.6 times 10 to the negative second times 0.1, I get 0.0016 minus 0.032x, and that's equal to x. So I'm going to move the x's to one side. And when I solve for x, it's going to be 0.0016 divided by 1.032, and that gives me 0.016. Okay. Now this is just the concentration of x. Now I'm running out of room here, guys. Sorry about that. I'm going to have to make this even smaller. So what does this mean? That means H2 concentration is equal to Br2 concentration because they're both x, which is equal to 0.0016 molarity. And we have to figure out the equilibrium concentration of HBr. So HBr, its concentration is 0.10 molarity minus 0.0016 molarity. So when you do the math of that, you get 0.098 molarity. Okay, so hopefully that helped you figure out how to do a calculation when you're trying to find the equilibrium concentration for all of the reactants and products. Please share with me a discussion or chat or inbox if you have any other